Hello. Today we're going to talk about rainbows. And it starts when I think about a story, it must have been almost 20 years ago, in one spring day, and I walked home from school after work, and my children, all three of my children were probably in elementary school at the time. And as I walked in, I mentioned to them, I said, "Hey, there's a great rainbow outside." And as elementary kids, they're pretty excited, and they all run outside, and they go outside and they look up and they spin around trying to locate the rainbow. And as I watched them, I realized I had never taught them how to find a rainbow. There's a very specific location in where you look to find rainbows. And you don't start by looking up. You actually start by looking down. And most people don't know this. And so I want to give you a little bit of understanding of how rainbows form and based on refraction. Okay. Now, let's not get confused. There's other optical things other than rainbows. You can see some pictures here. We have a picture of rainbow, double rainbows. You should know the sequence of colors. Of course, Roy G. Biv. If you look here down in the bottom, you have Roy G. Biv, red, orange, yellow, blue, indigo, violet. That sequence of colors from top to bottom. But all of this can be explained if we understand some things about refraction. Okay. There are halos, there's glories, there's other optical phenomena that occur in the atmosphere, and all of them are explained by some of the same principles. However, we are simply going to focus on rainbows. Okay. Now, one of the first scientists to actually study rainbows was actually Isaac Newton. Did a lot of stuff in not just calculus and kinematics, dynamics, but he did a lot of stuff with optics as well. So first thing we have to understand is that a raindrop is not shaped like that. That's what we call a teardrop. That's the shape of maybe water as it's about to tear away as it falls, or a droplet as it's sliding down, closer to the shape of something as it's sliding down the surface. But once the raindrop forms, or the drop of water has released, surface tension brings it into a spherical shape. Now, if it's a really big raindrop, you'll get it'll oscillate at a relatively low frequency. If it's a really small raindrop, very small, so small that you may not be able to see it, it would be spherical as well. However, the vibration, the frequency of vibration would be much higher. But we're going to basically say, hey, it is spherical. As it falls through the air, bigger raindrops will tend to get a little bit out of shape. But for the most part, on average, they are really quite spherical. And that's the assumption we're going to work with. Also, we have the idea here, if we look, we have the sunlight coming in. And as the sunlight comes in, we could draw a normal line at this point, and we would say, oh yeah, the light hits the water with a higher index of refraction than the air, and it bends towards the normal. However, the different colors bend different amounts. Red bends the least, blue bends the most, and so that explains this breakup of colors here. When you get to the back side of the raindrop, one of the topics we did not talk about was total internal reflection, but we get reflection on the back side, and then the light rays come here, and then they hit the other side, and we have refraction again, and the colors come out. And you'll notice that we have the high frequencies here on the top and the red on the bottom. And you might be looking at that and say, wait, we've got red on the top and the blues on the bottom. How do we get these two to agree? Well, it's actually quite simple. So I'm going to show you a diagram and show you how you find a rainbow, and so you'll never have this problem. So rainbows, of course, are rare, and the reason they tend to be rare is that you have to have a relatively bright sunshine, and it's got to be raining nearby. And typically, when it's raining, you get clouds and it blocks out the sun. So they tend to be rare. Okay. Now, the key, and this is the part I hadn't told my children, if you want to find a rainbow, you actually find the shadow of your head. Okay. So when the sun shines, the light ray is going to come here and it will cast a shadow of your head on the ground. And so we get, there's your shadow. The shadow of your head is called the anti-solar point. It's the point opposite the sun. Okay, so if you ever think there's somebody tells you a rainbow, look down, find the shadow of your head, and the rainbow will be a circle around the shadow of your head. Now, if you see someone take a picture of a rainbow, for example, in this first photo, right down here in the bottom of the picture, you'll see the shadow, presumably of the person taking the photo, and it's a circle around there. Now, there's not rain all the way around, and so therefore the rainbow is not a complete circle. But if you've seen pictures from an airplane, you can see pictures of a rainbow from an airplane, and it might form a complete circle if there's water in all positions. You can make your own rainbow, taking a garden hose and spraying it into little droplets with the sun or a light source behind you, and you can get this rainbow effect. And if there's water in all those positions, you'll get a complete circle. But typically the rainbows we see, because of the position of the sun and where your anti-solar point is, since there is not water in these regions down here, you don't get the complete circle. We only get the rainbow above. Okay, so now once we find the anti-solar point, then you can look up into the atmosphere and you might see a part of a rainbow or the whole thing. But how do we get that colors based on the fact of what we get here? And so the key to look at this is, let's take a look at, let's say, 3 raindrops. Okay, so what we're going to do is we're going to take a look at 3 raindrops. You can either think of this as 3 different raindrops with a picture of that taken at the same time, or we can think of it as the same raindrop at 3 different times. Either scenario will work in help explaining what's going on here. Okay. Now, as we recall, we look here at this picture, the reds are on the bottom, the blues are on the top. So what I'm gonna do is I'm gonna start by drawing the red. So each of these raindrops has a red light coming off the bottom, and these would be basically parallel. And then you would have blue light, or let's do the green one. The green one is, I like the blue. The blue is what I really want. The blue, that would be the other extreme. And then the green would be in between. Kind of messy, but that's what we got. So each of those gives off all the colors in between. Now, if we look at, so what light rays actually hit me in the eye? Well, what you'll find is that you don't get all the colors from the same raindrop or from that raindrop at that time. What you do is the light rays that hit you in the eye, this light ray gets it. So this raindrop actually looks red. The blue light ray travels over your head. The green one also travels over your head and you don't see it. Okay. If you look at the next raindrop, the blue one travels over your head. The red one might come a little bit lower. It's the green ray which hits you in the eye. So this raindrop looks green. And then the blue, the blue one hits you in the eye. It looks blue, where the red and the green fall down maybe lower on your body. So when you look up, you see red at the top, green, blue. But this raindrop, if this is one raindrop at 3 different times, as it falls, at first you don't see it at all because it's not in the region where you're getting visible light. And then eventually it falls into a region where that red light hits you in the eye. Then it falls a little bit further, and now it's still giving off all those colors, but now the green light hits you in the eye and it falls a little further, and the blue light hits you in the eye, and then it falls further and the other parts don't hit it. Now, beyond the red, you might see an infrared rainbow, or beyond the blue, ultraviolet. Okay. Now, you could think of this as 3 different raindrops at the same time. And this raindrop at the top gets you red, this raindrop looks blue, green, and the bottom one looks blue. Okay, now if you move to a different location, you're not going to be able to see you don't see the exact same rainbow. So when someone else sees a rainbow, they don't see the exact same rainbow you do. So if someone else is out here standing and they're looking at a rainbow, they may look at this raindrop, and that raindrop, that top one that looks red to you, may look green to them. And the one that looks green to you might look blue to them. And so everyone sees their own rainbow. And that's why when you move to a different location, you're always seeing the rainbow at a certain angle from you. It's about 42 degrees off of the anti-solar point. So if you find the anti-solar point and move to about 42 degrees off of that in all directions, it'll be a circle, you'll get the rainbow. But as you move, it's still that, so you can never get, it's not like it's an object there and you can walk to the edge of the rainbow. No, it's always going to be moving with you, so you always see a different rainbow than somebody else, unless you share the same anti-solar point. Okay, but that's the idea of the rainbow. So next time you look at a rainbow, or someone says there's a rainbow, look down. Find the shadow of your head, or if you're taking a picture of it, it'd be the shadow of your camera. Most time nowadays, people take photos with their phone or a camera they hold up to their face, and therefore the anti-solar point of your head and the camera are the same point. But if you have a camera on a tripod off to the side, it would be the anti-solar point of the camera. And then if you'll notice that, yes, it forms a circle around that point. And that's how rainbows form. Now, you might say, well, what is a double rainbow? Well, in a double rainbow, what you're actually going to get is you're going to get the light is actually going to take another trip around the inside and come out at a higher angle. Okay, the light you get reflection and refraction at this point, and it takes another trip around and it comes out. However, in the process, the sequence of colors gets reversed. So when you look at a double rainbow, the secondary rainbow, which is at a higher angle, is actually blue on the top and red inside. And you'll also notice when you look at a double rainbow, the region in between the rainbows is quite dark, because not a lot of light comes at you from those particular raindrops. So you have to view this as a curtain of rain, and these different raindrops are going to give you different colors at different positions. Hope that helps you understand a little bit more about rainbows.